Welcome back, everyone. Today we continue on in our Intro to Reduce series, and we're going to be talking about transducers. So, this one's going to be a bit of a doozy. There's a lot to cover, and I do want to say up front that we're only going to be talking about transducers in the context of arrays. Specifically, we're going to be talking about how to use transducers to transform the data in arrays. Transducers, as a general concept, should be able to operate on a bunch of different types of data structures, including streams and trees, etc. All right, as always, here are the prerequisites. I'd like for you to have an understanding of JavaScript, especially ES6 syntax. Hopefully, you've been following along or understand reduce already. I'd also ask for you to at least understand currying and partial application. I do have a video on that, and I will link to it below. The other thing is that you need to understand function composition, the idea that the output of one function can be the input to another. And that's it. So I'm going to try my very best to keep the context low by using some very naive examples, but hopefully it makes it a lot easier for you to understand the concept. So here's an example. So you see here we have an array of 1, 2, 3, and 4, just an array of numbers. We're going to transform the elements using map by adding 1 to them, and then we're going to use filter to only keep the even numbers. Pretty simple, right? Well, a pro here is that this is very easy to read. We kind of have this, left to right, top to bottom kind of flow. Another pro is that writing your code in this kind of dot chainy left to right style makes it very easy to reason about. And I like to separate those two things in my head, easy to read and easy to reason about. So for me, easy to read means, a cursory glance would give you kind of a high level understanding of what's going on. Easy to reason about means when you jump into the code and you actually look at it, that it's easy to diagnose, right? All the responsibilities have been kind of, delegated to their proper things. Map is for transforming, filtering is for removing, reducing is for, folding or, concatenating things together. But a con here is that we're iterating twice, right? Whenever we use .map and .filter, these array methods, they will iterate over the array every single time you call them. Now that's not an issue here because, we only have 4 elements. But as the, array grows or you have a lot of elements in the array, this might be a concern. The other con here is that map and filter both create intermediate arrays. And again, it might be fine if you're using a small data set, but as the data set grows, you may not want to do this. Now, how can we avoid these problems? Well, one way that we can do this without even using transducers is implementing map and filter in terms of reduce. In fact, I have a video on that very thing. So as you can see here, we've just taken all the things, all the operations that we would have done using map and filter, and we just kind of stuck it in this reducing function. We're going to transform the value, and then we'll run the predicate function over it, and if it passes the predicate function, we'll push that value onto an array. And this is very streamlined, right? In terms of it only creates one intermediate array, and it only iterates over the array one time. But an issue is this can become, bloated and hard to reason about the more that you keep adding things in this one function. You kind of lose this right to left, top to bottom kind of flow. Well, transducers are here to help. So transducers are higher order functions. And if you remember, a higher order function is a function that either takes as input a function or returns as output a function. But transducers are a specific kind of higher order function. They're going to take a reducing function and then return a brand new reducing function. You can think of them as factories for reducing functions. If you give a transducer a reducing function, it will just make you another one. All right, so remember the signature of a reducing function. A reducing function takes an accumulator, a current value, and it returns a new accumulator. The entire job of a reducing function is to make a new accumulator. Okay, here is the simplest transducer that you could ever write. It's essentially a no-op. It really is just a wrapper around the reducing function that's passed in. Let's step through the code. Okay, so it's going to take a reducing function, and this could be like add or a concat function or even a multiply function, any Any function that takes two values and kind of smashes them together, that's a reducing function. Well, you can pass that in, and it's going to return a brand new reducing function. The whole thing that's highlighted there is a reducing function. It'll take an accumulator, a current value, and then it will return a new accumulator. Now, this is just calling the reducing function that's passed in, and that will return the new accumulator. So this whole thing is just a wrapper around the reducing function. It's not very useful, right? Well, we'll get to that. So how can we use this? Well, let's step through the code. So we have a concat function, which is itself a reducing function. And I will note here, since we're using arrays, concat will create an intermediate array, which you may not want. And in fact, since we're talking about transducers, you probably don't want to do. So you could use .push here instead, but you'd have to remember to return the accumulator, because whereas concat will return the new array, .push will not. And we have our simple no operation transducer. Remember, it's just going to call the reducing function that's passed in. And so now we can create a new reducing function. We can do that by passing in concat as our reducing function. And remember, the whole job of a transducer is to return a new reducing function. And we can use it below, because remember that reduce takes a reducing function as its first argument. So this is actually what's happening. We've created a new reducing function that, when called, will just call concat that will, collect the items of an array into a new array. And you can see on the right-hand side, the elements remain unchanged. So let's look at this transducer one more time. Again, it's not very interesting, right? It's not doing much. But what if we wanted to modify the current value that's passed in? Let's go ahead and add 1 to it. We can assume that we're working on numbers right now, but as we'll see coming up, we can change that. So notice that the output has changed. We've essentially implemented Array.map, where we've taken an array of 1, 2, 3, and 4, and we've mapped over it, adding 1 to each element, and then we get an array with 2, 3, 4, and 5. So since we're assuming we have numbers here, let's go ahead and change the name of this transducer to add 1 transducer. What if we wanted to allow any transformation, like Array.map, where we would take a transformation function and then apply it to the current value before we actually do the reducing? How could we change the current transducer that we have to do that? Well, here's a solution, and it may remind you of Array.map. Let's go ahead and look at it. So now we have a function to actually create transducers for us, and it's called makeTransducer. It's like a factory for transducers, in the same way that transducers are like a factory for reducing functions. Well, this function is going to be a factory for transducers. If you squint, it kind of looks like Array.map, because we're taking a transformation function like add 1 or multiply by 2, or if you're operating on strings, you could do to uppercase, whatever you want. And that's going to return a transducer. The entire thing that's highlighted is the transducer. And the transducer, well, it's going to take a reducing function, and then when you call that, it's going to return a brand new reducing function. We've already learned this. Notice that we're actually going to call that transformation function on the current value that's passed into the reducing function. We're going to do that first. Now, it's important to know that this operation, the actual transformation, happens first before we call the reducing function. And we'll talk about why here in a second. So one of the great things that make transducers so easy to work with is that they compose with one another. So you can treat transducers like little Lego blocks and just move them in and out as you please. And that's because the output of a transducer, well, it's a reducing function. And the input of a transducer is a reducing function. So the output matches the expected input. All right, so a lot of things on the screen. Let's go ahead and step through it now. So you notice we have this compose function, and I've just called it compose transducers just so you know what it's doing, but honestly, this is a standard compose function. Now, it's important to know that these will execute from left to right. So transducer 1 will do its thing first, and then it will call transducer 2. Remember, transducers will transform the data first and then call the reducing function that's passed in. That's what we were talking about earlier. So I like to think of it as this. So you have your second transducer here, right? It's going to expect a reducing function. But remember that a transducer will do its transformations and stuff first. So it's almost like transducer 2 is saying, yeah, I know I have a reducing function here. I'm going to call you, I promise. But before I do, I'm going to go ahead and transform the data before I send it into you. And then when you actually call transducer 2 with the reducing function, well, what does that return? It returns a brand new reducing function. And so this reducing function that gets created by using this transducer is passed into this first transducer. And again, this first transducer will say, all right, I know I have a reducing function. I promise I'm going to call it. But before I do, I'm just going to transform the data before I pass it in. But because of the way that transducers operate, transducer 1 will happen first. Then transducer 2 will happen. So even though this is just a standard compose function, it's going to operate slightly different than you may expect. Okay, so now that we have the idea of composing transducers under our belt, let's create a new transducer. We're going to call it add one and double transducer. It's going to be the composition of the two transducers above, add one transducer and times two transducer. So again, even though we're using a standard composition function here, add one transducer will happen first. It's going to transform the data, and then times two transducer will happen. So then we can use concat, which is a reducing function, to create a new reducing function because that's the job of a transducer, and we can pass it along to reduce. And if you notice, we've taken the array of 1, 2, 3, and 4. We first added 1 to it, so we get the array of 2, 3, 4, and 5. And then we double that to get 4, 6, 8, and 10. So we've handled transformations, but what about filtering? Remember that first example that we had where we were removing odd numbers, or you could think of it as we were keeping even numbers. Well, we're going to talk about that in part 2. So this is a lot to digest already. And if you're not getting it or if you're stuck, don't worry. If you need to pause the video or watch it a few times, take notes, tinker, and go line by line and just question, everything that's going on. But I will say this, if you can understand one thing from this video, if you can understand that simplest transducer, the one we did at the very beginning, if you can understand why that works, you can understand anything else that we talk about. All right, if you've made it this far, and if you're up to it, I have some homework for you. So, as you can see below, we have an array of lowercase a, b, and c, and we've created an uppercase transducer that will just transform lowercase letters into uppercase, and we pass in concat so that we can get a brand new reducing function that will collect all of the transformed elements into a brand new array, and we pass in an empty array as our accumulator, and then we get an array of uppercase a, b, and c back. And that's it. So again, in the next video, I'll be covering how to use a filtering transducer to remove or keep elements based on some predicate function. We will also go over how you can actually compose mapping transducers with filtering transducers together and create very powerful data transformation pipelines. So as always, if you liked the video, leave me a comment below. And if you didn't, well, let me know about that too. And don't forget to hit the like and subscribe buttons as well as the bell icon. And I'll see you next time. Thanks.